Srimati S. Saranya. She pursued her Bachelor of Engineering in Electronics and Communication Engineering at the J.J. College of Engineering and Technology, Trichy. She then went on to pursue her Master of Engineering in Applied Electronics at the Satyabama University, Chennai. She is currently working as an Associate Professor in Dhanalakshmi Srinivasan College of Engineering and Technology, Chennai. She has published several international and national journals as well. Her areas of interest include medical electronics, electronic circuits, electronic devices and circuits, mobile communication, digital electronics.
Welcome to UGC lecture series BSc Applied Electronics. This module deals with application-oriented subject medical electronics. In this lecture, we are going to discuss about the recording systems, specially called as biopotential recording systems. So, two recording setup we are going to discuss today. One will be EEG and another one will be ERG. EEG represents electroencephalogram and ERG represents electroretinogram. So, first we can see the content of the lecture. Introduction about electroencephalogram and what are the action potentials we are going to measure using EEG. Then brain waves, types of brain waves. So, in types of brain waves we are having specially 4 types: alpha, beta, theta and delta. Then placement of electrodes in the EEG measurements. So, here we are going to place the electrodes in the patient's skull position. So, overall it will be using 21 electrodes used for this measurement. Then recording setup of EEG and modern EEG unit available for recording the system. Then analysis of EEG. So, because of this dysnormal waveform of EEG, what are the disease we are going to discuss in the analysis part. Then that is introduction of ERG, electroretinogram, and the placement of electrodes in the position of electrodes in the ERG, then recording setup of ERG and waveform produced during the measurement of ERG. Then we can go to the lecture. So, briefly you are going to discuss about EEG, electroencephalogram. It is also called as electroencephalography. It deals with the recording and study of electrical activity of brain waves. So, we are going to place a electrode on the skull of the patient. From the electrode position, we are going to pick up the brain waves and it is recorded using the setup. So, when you consider this brain waves, it is a summation of the neural depolarization in the brain due to the stimulus. So, we are going to give some external stimuli to the patient. So, because of that, we are going to see what are the changes what are the changes happening in the brain activity, and we are going to record that waveforms. For example, we can visually give stimulus or else you can give audio stimulus or touch stimulus. So, this is the various types of stimulus. External stimulus we are going to give to the patient and undergo the process measurement. The potentials measured because of the position of the electrodes will be changing. When you use electrodes with a distance of 20%, the measure that is potential produced by the brain waves will be different. If it is 10%, that is distance between the two electrodes are 10%, then the potential produced by the patient will be different. So, because of the that is position of the electrode decides the potential produced by the patient, then it is converted into brain waves. Then position of electrodes and properties of electroencephalography. So, where we are going to place these electrodes? Already we have discussed we are going to place the electrodes in the skull part of the patient. So, it has a basic 4 concept with this position. So, first one will be frontal and then parietal and then temporal and then occipital. So, lobes of the brain. So, we are going to place the electrode all over the skull part, these 4 positions. The voltage produced during the measurement will be about 10 millivolt, and the frequency range of this measurement will be between 0.5 to 3000 hertz. Then attenuation, when you are measuring the brain waves, we will be going for the attenuation levels. So, it will be between 1 to 100 microvolt. So, already I told you this electroencephalogram, it is otherwise called as electroencephalography. Then origin of electroencephalogram. So, first that is invention of this EEG measurements, we have used action potential alone to measure the brain waves. So, this action potential is created because of the neurons in the brain. Now, we are going for the graded potential. What is graded potential? So, when you pick up the brain waves, it will be the summation of the dentatories of the neutrons in the cerebral cortex. So, this will be producing the graded potential that is picked up by the electrode, and the average of the graded potential is produced in the output of the recording system. So, the graded potential or the variation around the average value of the resting potential. So, these two types will not have much difference, just you are going to differentiate the potential alone. Graded potential will be the average of the potential. The great number of potentials are summed to produce a EEG. So, it is not a single potential you are going to get from the skull portion of the patient. So, you will be using n number of electrodes. So, that n number of electrodes will produce different types of action potential. So, it is a summation of the action potentials and it is summed up and the EEG waveform is produced. So, the discharge of a single neuron in the brain cannot produce any recording of EEG. So, first in the measurement, the first step will be considering a tremendous number of neural fibers will be discharging synchronously. So, that will be created by the very strong electric current. So, it generates a very strong electric current. Secondly, a large number of neurons are partially discharges, action potential or not emitted. So, in the first case the nerve fibers will be discharging synchronously, hence we will be going for the recording. In the second form the neurons will discharge partially, hence there will be no producing of action potential, hence it will not produce any recording of EEG waveforms. So, then we can detailedly know about the action potentials of the brain related with the EEG measurement. So, the resting potential along the nerve fiber is used to transmit the information from one end to another. When you consider this nerves and cells, how it produces the action potential. So, when we are giving the external stimuli, it will be propagated through the cell and the cell will be fires. Because of the firing of the cell, it produces spike waves. So, it is recorded for the output purpose. So, we are having basically two types of measurements. One will be inhibitory post synaptic potential IPSP and another one will be excitatory post synaptic potential EPSP. So, first IPSP means it will be produced in the inhibitory state in which neurons will increases in the negative direction, hence there will be less likely discharges. So, it will not produce that much potential charge will be induced at the output. When you consider the second one, here the transmitter substance will be excitatory. So, the member potential will be member potential of the receptor neuron will be increasing in the positive direction. So, it will be more likely to discharge and it produces the spike potentials. So, this is a difference between the two types IPSP and EPSP. So, then we can go for the measurement waves, that is brain waves. The brain waves is produced because of the electrical recording on the from the surface of the brain or the outer surface of the head. So, it is a continuous process and the intensity of the brain waves will be ranging from 0 to 300 microvolt. So, already I have told you in the introduction itself, in brain waves we are having 4 basic types: alpha wave, beta wave, theta wave and delta waves. So, how these 4 types varies means because of the frequency produced by the waveform will differs these 4 types. The diagram shows the 4 types of waveforms: beta wave, alpha wave, theta wave and delta wave. So, in the diagram itself we have represent the frequency range of each and individual waveforms. So, according to the frequency range produced by the potentials, the waveform will be differentiated. When you consider this beta wave, the frequency will be ranging from 14 to 30 hertz and it will be because of the mental activity produced by the person when he is in awake position. And then when you consider alpha wave, the frequency range is between 8 to 13 hertz. So when it will be created means the person will be in awake condition and also in the resting potential or resting state. So this alpha wave is produced. Then theta wave is measured under the frequency range of 4 to 7 hertz in the sleeping position. So this is common for both adults and children. Then last delta wave, it will be below 3.5 hertz. So it will be produced in the deep sleep condition. So here we are having various properties of this alpha wave, what is discussed in the diagram. So what is the frequency range and which condition, in when conditions it will be occurring, and then what is the amplitude range also. So the delta wave will be between 0.5 to 3.5 hertz. Then we can move to the next point. It will be placement of electrodes. So already we have discussed more about the position of the electrodes. So we are going to place the electrode in the skull position of the patient, and it varies according to the types of instrument and then the surgeon. So the distance between the electrodes will decide the potential produced by the brain waves. So here we have used 20% of the distance between the each and individual electrodes. So basically we have discussed about that 4 basic position. So frontal position, partial position, and then occipital positions, and then other one. So these all electrodes will be coming under the 4 different position of the electrodes. So this is a top view of the electrodes placed in the skull surface. This is a left view of the electrodes placed in the skull surface. So to differentiate the each and individual electrodes, we have named it in different form. F, that is it starts from F3, F4, F7, F8, then FZ. So the central lines will be covered with this Z value, CZ, PZ and FZ. So here it comes a block diagram of electroencephalogram. So before getting into the recording setup, we have to understand what are the blocks and what are the external measurements we are going to position other than the electrodes. So we are going to use amplifier. Then this amplifier contains preamplifier and bioamplifiers. Then we will be having a control unit used to control all this recording setup, and then driver amplifier. It is used to pull up the measurement section towards the recording, to the output of the recording. So here we are having n number of stages. It starts from stage 1 to stage 5. So because of this n number of stages, we will be getting more amount of gain in the amplifier stages. So different 3 stages we are having, and then separately we are giving input to the 3 stages. Let us have a small break. Welcome back after the break. In the previous section we have discussed about the block diagram of EEG. Then we can move to the recording setup of EEG measurement. So here we are having I am having 3 different recording setups. So the first one is a external recording setup. So here we are having a patient, and then we are placing the electrodes in the skull portion of the patient, and then it is measured in the neuroscan using 3 or 4 amplifiers in the neuroscan unit, and then we are having a stimulus computer. From this we will be giving the external stimulus to the patient. So it will be in the form of video or audio. So then after the neural scan synchronizing amplifiers, the signal is passed into the acquisition computer. So where it that is the waves measured by this neuroscan will be recorded for the future purpose, and it is also displayed in the output unit. So it is also displayed visually or in audio format. Here comes another modern EEG unit. So here we are having in detail measurement. So here the position of the skull, that is patient skull position, then the placement of electrodes, and it is connected to the amplifier circuit. This amplifier circuit gets input from each and individual electrodes that is placed in the skull of the patient. So this all waves will be recorded in the amplifier circuit. Either it will be boost steps or the level will be continued. Then it is passed into the filter. We are having possibility of 3 types of filters: low pass filter, high pass filter, and any other filter we can use. So this filter is especially used to remove unwanted signals or any distortion present in the output. So it will be removed to get the clear output in the recording setup. So then all those signals is displayed in the output recorder. That is, output from the amplifier circuit is controlled by a external CRT and then signal processing unit. So the signal processing unit is used to control the variations in the signals, and then CRT is also used to display the output. So either we can display the output directly after passing into the amplifier circuit, or else it can also pass through the filter and it is also displayed. So either any form of displays can be used. Then recording system, it is a very simplest recording system. Here we are having a patient, and then electrode is placed in the position of the skull. So here we are using only 2 positions of electrodes. Then it is connected to the amplifier circuit. This amplifier circuit collects the signals from the electrodes and it is passed into the output recording system. So this in the output recorder we will be using a pen shaped writer. So because of that signal produced by this measurement, the shape of the waveform will be decided. So this mainly depends on the voltages, that is amplitude levels and time levels of the signal produced by the amplifier. So it is displayed in the graphical format. Then we can see briefly about the recording systems. So the patient cable is connected to 21 electrodes and also 8 channel selector. So this 8 channel selector is used because of the different types of waveform measurements. Then right electrode, that is electrode placed in the right ear, will be acting as a reference electrode for the right brain electrodes, and then left ear electrode will be acting as a reference electrode for the left brain electrode. So these 2 points should be compulsorily monitored when you are placing the electrodes in the measurement setup. So we will be using differential amplifiers, pre-amplifiers, bioamplifiers. Because of these amplifiers, we will be getting more CMRR value, will be more than 60 dB decibels. So the CMRR is common mode rejection ratio. So this EEG measurement will be placed in a room which will be covered with ferrous metal screen. The input impedance of this pre-amplifier used in the recording setup will be more than 10 mega ohms, and the cascading of the given amplifiers will be increased up to 10 power 6. So we are using 5 stages of amplifiers. So because of that, the gain will be increased, that will be in the order of 10 power 6. So when you consider the output voltage of the amplifier, so it will be applied directly to the 8 channel display through a filter bank, or it will be directly stored in the tape recorder for the future purpose, or it can also be stored in the computer memory. So when you consider this filter bank, it will be having appropriate filters for selecting different types of brain waves. So we will be giving external stimuli. We already I have told about the external stimuli. What are the external stimuli we will be giving when going for the measurement: visual, audio and touch series. So the time delay between the stimulus and the response given by the system will be controlled by using a signal processing unit. So the signal processing unit block we are having in the recording setup. So then analysis of EEG. So a physician has to, the EEG waveform will help the surgeon to diagnose the level of consciousness. So how the patient is, whether he is normal or having any problem related to the brain. So it can be any any disorders, for example sleeping disorder, brain death, brain tumors, and then multiple sclerosis. So when you consider the first level of consciousness, so that EEG waveform recorded by the recording setup decides the level of consciousness. So this can be because of diminished mental activity result in the lower frequency, and it can be in the large amplitude. The EEG has more valuable contribution towards the study of the sleep physiology. When you give anesthesia to the patient, the brainwave frequency will be decreasing until the amplitude will be increasing. So these will be under the level of consciousness. Then we are having the different waveforms produced by the level of consciousness. So it differs from one another. When it is awake, the waveform will be different. When a patient is awake, the waveform will be different. When is lightly sleepy, the waveform will be different. And then it's starting to REM of sleep, the waveform will be different. Deep sleep, so the waveform will be like this. And then death, the waveform will be a plain horizontal line. So the analysis will be continuous. The second analysis will be brain tumors. So what are the factors related to the brain tumor? So when you distinguish or damp the EEG waveform, so over a certain part of cortex, it will be producing the sign of tumors. And the last one will be epilepsy. So it is also as one of the type of disease, and it gives a symptom of the brain damage. So the brain is going to get damaged, it will be indicated using this. So it can be because of defect in the birth delivery or head injury during the accident, or any other type of injuries. So when you characterize this epilepsy, it will be a synchronous discharge of large group of neurons. So then we can move to the second type of recording system, ERG, electroretinography. So this measures the electrical activity of eye. So when you consider all the sense of organs will be connected to the brain, but the eye will have a special relationship as a retina in the extension of the cerebral cortex. So it will be different. When you go with the cornea, it will be about 20 millivolt positive to the fundus of the eye. This fundus of the eye will be in the interior of the eyeball. So the electrode specially used for this measurement is AgCl, that is silver chloride. So it will be having on it will be in the contact lens, and will be and another distant electrode will be on the cheek. It is used to record the eye potential changes. So next, how the electrodes are placed in the ERG measurement. So especially we will be using bipolar recording techniques. So here the exploratory electrode is placed on a saline filled contact lens, and then the contact lens will be tightly attached to the eye of the patient. This common contact lens used will be mainly used for the corrections or cosmetic purpose. For the measurement of eye potential changes, we will be using a special type of contact lenses. So some of the special contact lenses are used to record the potential produced by the eye movement. So how it is recorded? So first you will be flashing flash a light on the eye. So because of that light, what is the difference in the eye movement, and it produces the potential of the eye, and it is recorded. So then the recording techniques of ERG. So first we will go with the format, that is when light incident on the eye, what happened. So when light falls on the retina, the absorption of the photons by the photopigments can be localized. So it will be resulting in the development of action potentials, and it will be transmitted through the optical nerves. So the action potential is picked up by the electrodes, and it is fed to the bioamplifier, and then it is recorded. So the recording setup of ERG is similar to the ECG measurements. So this ECG is electrocardiogram. So we have already discussed about the ECG. This diagram shows the typical ERG waveform. So here we are having two conditions, on and off condition, and then the areas will be the area of the waveform will be separated by three forms, A, B and C. So in this position what happens, and then if it waveform increase, what happens, that slightly it will be maintaining constant and it will be increasing, what happens. These three positions are specially discussed. So when you consider the waveform, when a flashlight incident on the eye, a constant DC, so before going into the measurement, so there will be a DC horizontal line will be displayed in the output of the recorder. Then when the flashlight incident on the eye, then action potentials produced by the eye movement will be recorded. So the response will be getting within 2 seconds. Then because of that potential, your ERG waveform will be developed. So in the first wave position, that is A position, this A position is because of the response of the flash of light in the due of the early receptor potential, ERP. So it is generated by the incident light and it will be induced in the photopigment. And the second position of the waveform will be B, slightly increasing. So it will be with the delay of 1 to 5 milliseconds, and it will be coming under the later receptor potential, LRP, and it is produced at the end of the photoreceptors. And the third position, C on the waveform, so after B it will be slightly maintain constant and it will be increases further. So this is because of the offset of the light stimulus. So after that it will be no light will be incident on the eye. So this diagram shows the ERG recording setup and also the position of the electrodes in the various parts. Then summary of the section. So from this lecture we can understand what is a EEG measurement, how it is measured, and then what is the recording setup of EEG, and where we are going to place the position, that is place the electrodes in the patient, and because of the position of the electrodes, the EEG waveform potential will be varying, and different recording setup of EEG, and then analysis of EEG. Then second type of measurement, ERG, electroretinography. So here we have measured how the eye movement is recorded as a potential, and then where we are placing the electrodes, and then recording setup of ERG. So from this lecture the student may able to answer the following questions. So how the action potentials of the brain is measured using EEG, and what are the brain waveforms, and draw the diagram of brain waveforms. So how the electrodes are placed in the EEG measurements, and then explain briefly about the recording process of EEG, and discuss about what are the uses of ERG, electroretinography, and then explain the electrode placement and waveform of ERG. Thank you.